So we have seen many kind of trees, tree traversals, and different tree kind of operations, how to insert, how to delete nodes, what is the purpose of each and every tree, what is the purpose of binary search tree, and what kind of operations we can perform, and what is the purpose of AVL tree, what is AVL tree, how we could come from binary search tree to AVL trees, right? And red black tree also we have seen what is the purpose of red black trees, why we have to go with red black trees, so everything we have seen. So in module 5, no doubt in it till now? Yes guys, no doubt in it? Different types of tree
Yes,
traversals, binary search trees, AVL trees, and red black trees. Is it all clear to everyone?
yes, ma'am.
Guys, you also can respond. Others?
Yes, ma'am.
Yes,
Yeah,
ma'am.
thank you, Neetu. Thank you.
Yes, ma'am.
Okay, guys. So now we will see one more kind of tree, that is threaded binary trees. Okay, threaded binary trees. For example, we can use linked list data structure to create, to show this hierarchical representation and to create any kind of binary tree structure. Correct. Even we can perform this with array, and last class we have seen how we can create a tree with linked list pattern also. Correct. And usually we used to have a linked list data structure only to implement this tree kind of structure. There you just consider all the leaf nodes. Okay, okay, I will give in written different way. For example, 3 nodes are there. Okay, then how many leaf nodes? Then how many leaf nodes? In binary tree, totally 3 nodes are there. Okay, how many leaf nodes can be?
Ma'am, 2.
Only one are answering. Is there any tough question I asked?
No, ma'am.
Just imagine in binary tree, imagine 3 nodes are there. So how many leaf node we can have?
Ma'am, 2.
Yes, exactly true. Yes. So for example, 5 nodes I am having, or 6 nodes will take. 6 nodes I am having. So maximum how many leaf node can be? You just draw roughly. You just draw roughly and try to find it out. Maximum, for example, 5 nodes are there, or 5 nodes will keep. 5 nodes are there. So maximum how many leaf node can be? If it is 5 nodes means how many leaf node can be?
Ma'am, 4.
Okay. The same way, if I'm having 1000, so that time I may have n minus 1
900.
number of leaf nodes. Correct.
Yes, ma'am.
So that time, if I implement linked list concept, so the all the leaf nodes left and right memory will be waste. This point you people are agreeing or not? Can you imagine what I try to convey? See, I will show in paint. Is it visible, this one?
Yes, ma'am.
Yes, ma'am.
Yeah. Oh, thank you guys. Just imagine I'm having like this. Just normal binary tree. I'm not talking about any binary search tree and all. It's normal binary tree I'm talking about. I'm having like this. Okay. So only 2 or 3 portions I will have, because left pointer, right pointer I should have, right? So just I'm drawing roughly. Okay. So this pointing to this node and then right side pointing to this node. Correct. Here any left side point this node this
No,
place
ma'am.
is pointing any left side subtree?
No, ma'am.
No.
No, ma'am.
No,
So
ma'am.
so it will be treated as
Leaf node.
leaf node, but this memory, this space we
Null.
will keep null node. Correct.
None.
And this also will be null.
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 And here also it will be null, and here also it will be
Null.
null. And I can consider I'm having values like 1. It is just normal binary tree. So there is no rules in numbers, no left, no greater rules. Just imagine. But if I want to insert one more value, so what is the first step I should do? I want to insert one value. What is the first step we should do? First, we want to create. First, we want to create.
Node, ma'am.
Exactly. First, we want to create node. Okay, with with because the node is common with left side memory,
And
and
right
I
side.
should give space for data and also for right side.
Right.
Correct.
Right side.
Yes, and then I can join wherever I want to join. For example, I am joining left side. Okay, I'm just joining left side. So now it won't be null. Chandrasekhar, Chandrasekhar, you could respond me. Okay. So, for example, I added like this. Say, for example, any other values. Say, for example, I'm having 3, 4. Okay, like this. Okay. So, whenever I'm creating new node, always I'm pointing. Yes. What happened?
Ma'am, Karthik here, ma'am.
Yes, yes, Karthik.
Ma'am, heard that you were calling me, ma'am. So,
Yeah, you could able to hear my voice, right? Then where you went?
no, ma'am, actually I was in hospital, ma'am.
What
My
happened?
dad was injured, ma'am. My dad was injured, ma'am. So, I was in hospital.
In traveling or
Yes,
how?
ma'am.
Okay, okay. Which state you are?
Ma'am, from Karnataka only.
Karnataka only. Okay. Now, how is he?
Yes, ma'am. Now he's little pain is there, ma'am.
Okay.
That muscle something happened, ma'am.
Okay. Whether hospitals are allowing to stay there or after taking treatment you have to go home?
No, ma'am. Actually, separate hospitals have been made, ma'am.
Okay, okay, okay.
Apart from COVID-19,
Oh,
the separate
okay.
hospitals are made. Yes, ma'am.
Okay, okay. They are taking care.
Yes, ma'am.
Okay, okay. Okay then. Regarding profile picture only I told, then try to update by tomorrow. Okay. Don't forget it.
Yes, ma'am. Yes,
Just
ma'am.
for security issues. Yes.
Yes, ma'am.
Yeah. Okay, guys. Okay, we'll come back. So whenever we are creating new node, always we'll put value and both left and right pointer will put as which value will put?
Null.
Exactly,
Null.
null value. Correct. So this is the state now. Now, so anyway, whether I'm having left node, whether I'm having right subtree, okay, irrespective of that, whenever I'm creating new node, anyway, I should create complete memory for that because struct node inside int data, struct node star left, struct node star right. So it is a space I should create for each and every node. Just consider this is our tree structure. Just consider this is our tree structure. So whether I'm using or not, how many null values here I'm wasting? In linked list pattern, how many null space I'm wasting? Can you tell?
What, ma'am?
How many null space I'm wasting? How many memory location I'm wasting it?
Ma'am, 5.
5,
5
ma'am.
memory location we are wasting. But anyway, allocated memory. For example, my memory start from 3000. Okay, anyway, I create, for example, this location is 3000. This node's location is 3000. Anyway, create a node. So for this right side address pointer, it already allocated 4 bytes, and for data maybe 4 bytes, and for right pointer maybe 4 bytes. Correct. So totally 12 bytes I am allocating. Though I am using or not using, it is fixed. I am allocating. Correct. This point understood, everyone. Though I am using or not using, anyway I have to create. So what happened? All these null spaces are going waste. That memory are going waste. That point you agree with me? All this
Yes,
null
ma'am.
memory are going waste. Yes?
Yes, ma'am.
Okay. Only if you are responding. Respond me, guys. Antima, Arshia, are you getting?
Yes, ma'am. Yes, ma'am.
Kavya, why are you not replying today? Geeta Rani, are you getting all the things?
Ma'am.
Yeah. Okay. So the idea of threaded binary tree is they are trying to utilize this null space. Okay. In some other way, we have to use this null space or use this memory to for some other purpose. So we'll see in what way they are using this null space. For what way they are utilizing this null space, we'll see. That is the key idea of threaded binary trees. Whether this Word document is clear, visible, Word
Yes, ma'am.
document? Okay. Okay. For example, in order traversal we want to do in binary tree. So we have to apply recursion, correct? We have to keep on call, we have to call again, then we have to read, we have to go left until the end, we have to go left and then root node and then right. So how we implemented using recursion only we implemented, but using threaded binary tree, they are making very easy of those tree traversal in very easy way and very speedy way. By utilizing this null memory, we will see how we can utilize. By utilizing this null memory, they are making tree traversal very easier one without using any recursion concept. Okay. So there are two types of threaded binary trees. One is single threaded, another one is double threaded. Okay. Better I will explain with an example so you will understand better. We will come back to same. We'll start with very simple example. Okay. For examples, values 1, it may be 2, it may be 3, and 4. Since it's only just a binary tree, we are not following any rules other than that each and every node can have maximum 2 child nodes. Okay. And I'm trying to link. So left side, I'm having trees pointing this node, and right side, yes, I have a child, so I'm pointing this node. And then for this tree, yes, I'm having left side child, I'm pointing, and yes, I'm having a right side child, I'm pointing this node. Okay, so whenever we are creating node, so all the time, this both left and right will be null. Okay. Okay. So how many null space are getting wasted here? Totally I'm having 5 nodes. I'm implementing using linked list concept. So for 5 nodes, how many null space I'm having? How many null
Ma'am,
space?
6.
So 6 null space I'm having. So what they are doing? So there are 2 points. Okay. There are 2 points. Number 1, join all left null pointer to its in order predecessor. Okay. And join all right null pointer to its in order successor. Okay, so first this is binary tree. Can anyone tell what is in order traversal of this tree? Can anyone tell
Yes,
in order traversal of this tree? Can anyone guess? Can anyone guess in order traversal of this tree? This much time.
Ma'am. 2, 1,
2, 1,
then
3, 4, 5.
3, 4, 5.
yeah, 2, 1, 3, 4, 5. Correct. Okay. So what is our rule? Join all left pointer to its in order. So, and before that, one more point is also there. We have to keep, okay, third point I'm mentioning. Keep leftmost and rightmost null pointers as such. We will see why we are keeping as such. You itself can guess the answer. Okay, so we'll follow first 2 points. Join all left pointer to its in order predecessor. Okay, this is left pointer, correct? This is left pointer. So where I should point it? Where I should point this? This is my left pointer in order predecessor. Predecessor means the node which is traveled before that, correct? So in order travels, which is traveled before that, which number is traveled before that?
4, ma'am.
2.
4.
2.
4, ma'am.
Predecessor I am asking. Predecessor means before.
1.
Ma'am, 4.
1, ma'am.
Why 4? Predecessor
Can you
means,
ask again?
see,
predecessor of 2 का 1, 3 का 4, 5 का 4.
yeah, see,
Predecessor of
I am
2 नहीं
asking predecessor. Predecessor means the node which is traveled before that. See, if 1 is node, 2 its predecessor. If 3 is node, 1 is its predecessor. Predecessor means the node which is traveled prior to that. Successor or for which is following that. So if 3 is a node, 4 is a successor node, next node, succeeding node. And if 4 is a node and 5 is a successor node. Understood that? Guys, it's
Yes, ma'am.
clear?
Yes, ma'am.
Let me take the same example as what they shown here. This. Okay, I will take the same example. See, there are 2 types they are telling, right? What is this 2 types they are telling? Single threaded and double threaded. What is a single threaded? Null right pointers is made to point to its in order successor. That is only null pointers, null right pointers utilizing. Single threaded means we are utilizing only right pointers. See, everyone could see this paint screen? Everyone could see this
Yes,
paint
ma'am.
screen?
Yes,
Okay.
ma'am.
Now let me know the in order traversal of this tree.
What, ma'am?
In
Ma'am,
order traversal
one,
of this
1, 3, 5,
one, three, five,
5, 6,
1,
9,
3,
5,
5,
6,
6,
6,
ma'am, 9,
9,
11, 13.
9, 9. No, before 9, 7 I can travel, no?
yes,
Yes,
ma'am.
ma'am.
7,
Yes, ma'am. 7,
Okay.
7, 8, 9, 11,
8,
13.
9,
11, 13.
7 and then 8 and then 9,
8,
9,
11,
11,
13.
13.
13.
Right. Okay. So let it be. So if it is single threaded, what is the rule? If it is single threaded, what is the rule? We are just
Null,
utilizing
right pointer.
right null pointer. Okay. So you just imagine the one. So we are just showing the only node pattern, but really what like this, right? Correct. Each and every node showing this structure. Correct. I'm utilizing what? I'm utilizing only
Null,
right
right.
pointer.
yes, right
Right null
space. So
pointer.
where I have to point successor. See, if
Successor.
one is a node, what is a successor?
3, ma'am.
Yes, I'm connecting to 3. Okay. Then is there any null space over here? And here also, for example, this is a structure and I'm just utilizing only right pointer. So right pointer where I have to join? Right
6,
pointer where I have to join?
six.
In order successor. Yes.
Yeah, ma'am. Yes, ma'am.
So 5
Yes,
is my
ma'am.
node. I am connecting to in order successor. Correct. And what else is there? Any other leaf node? 7 is also one leaf node. And I'm utilizing only right pointer. So what is the successor of 7? What is successor of
8,
7? 8.
8, ma'am.
And any other leaf node? Yes, 9. I'm just utilizing only right. Okay. What happened to Kavya? Whether she disconnected? Okay. So what happened to 9? The successor of 9 is 11.
11.
Correct. I'm just joining it. And again 13 is also leaf node,
Right pointer.
but
Yeah,
I'm
ma'am.
checking right pointer, but I don't have any
Successor
successor.
in
So I am leaving as such. So that is why they're telling rightmost pointer, rightmost nodes null, you leave as such. Because what? That node don't have any successor. You understood why they added that point? Yes? Because
yes, ma'am.
rightmost
Mhm.
node, it doesn't have any successor to follow it. So always we are keeping as null. This is called single threaded. What we are doing? So it makes easy of tree traversal. So just I'm coming to leftmost and I'm just following to the in order successor using what?
Successor.
Using this thread. This thread means this thread having the address of this in order successor. I know it, this is the successor. Then I am coming to next node. Then it have the link. So I know it which is the successor. Then I am coming down to the leftmost. I know it after 7 I have to go here. Then I am coming down going to leftmost. After printing this I know it I have to come back here. So I don't want to use recursion because then and there I have a address value itself where I have to travel. Correct. This makes
Yes, ma'am.
tree traversal little easy because anyway we can utilize this memory space also. Anyway, it's already memory allocated. So we are trying to utilize this memory. Okay. This is what single threaded. And we will see with double threaded. Guys, 1 minute, Sarah is calling. Okay. Whether it is visible, the screen? Guys, whether the screen is
No,
visible?
ma'am.
No,
ma'am.
ma'am.
Okay, okay,
No,
1
ma'am.
minute. 1 minute, I will check. Okay. Okay, just look into that. So here what we are doing, we are utilizing both. No, here they just utilized only successor. Okay. So we'll see the usage of that. As I told, see this example we just now we have seen they're utilizing right null pointer to
Right.
pointed
Ma'am?
successor.
Yeah, ma'am.
To points is successor, correct? And we'll see that with how we can use that. We are just starting with the leftmost node. We are just printing. Okay, they are explaining how it can be helpful for us. And it is showing we have to go through right. So it is travel to right. We are printing. Because here we are not using any recursion, correct? It makes the traversal very easy. 3 we printed. And then coming down 5 we are printing and it have another route, that is I have another link where to go. 6 it is getting printed and I have to come to whether it is visible. Yeah, half image is not visible, I think. Okay, and then I'm coming down to leftmost 7 I'm printing. So I have successor because in order successor I know which to travel next. So 8 I'm printing. I'm coming down to the leftmost 9 I'm printing and I have a new I have message, I have address where I can go to travel the successor. So I know it because I'm having address. So after 9 I'm going 11 and then 13. It's clear
Yes, ma'am.
because it makes traversal easy. But and one more thing is also possible. Wait. Now paint screen is visible.
Yes, ma'am.
Yeah. Now
Yes, ma'am.
okay guys. I'm just deleting everything with same diagram. That is till now we have seen how we can utilize the right, but still we can use both in order and post order traversal also make it easy. So we can utilize both left and right pointers. So how I can utilize left right pointer? I have to point it in order predecessor, correct? So
Yes, ma'am.
you consider this number 1 like this, number 1 like this. Already I pointed rightmost. Yes, already I pointed right null pointer. Yes, guys?
Yes, ma'am.
Okay. But and left also I can do. How I can do? Left also I can do. How I can do? That is I have to point it's in order predecessor. So whether I have any node to point at any I have node any predecessor I have any predecessor I have. Number 1
No,
I'm
ma'am.
talking
No,
about
ma'am. No, ma'am.
right side null pointer utilized with successor and left pointer I'm just checking I point to my in order predecessor. Any predecessor I have?
No, ma'am.
No. So that is why they told the leftmost node's left pointer should be null. Why? that node don't have in order predecessor. Guys, you got that point now?
Yes,
Number
ma'am.
one, you have to keep leftmost nodes left pointer null, also rightmost nodes right pointer null. Why? Because we know very well, because that node, leftmost left node definitely don't have any predecessor. Rightmost nodes rightmost node definitely don't have any in order.
Successor.
Very good, in order success. That is why we are keeping this as null. Okay. Okay. And we will come back to number 5. Okay. Number 5, I already pointed to the in order successor. Also, I can point to the in order.
Predecessor.
What is in order
Predecessor.
predecessor? What is in order
Predecessor.
predecessor?
3, ma'am.
1, 3,
I can
Three.
point like this.
3.
It will be helpful for my post order in order traversal anyway. I can use. And what is the leaf node? Here also 7 I'm having. What is in order predecessor?
6, ma'am.
6. So I'm pointing to, I'm utilizing this null pointer in this way. And any other null pointer? Yes, 9's left is free. And 9 left, where I have to point in order predecessor.
8.
Where I
Eight,
should
ma'am.
point?
8,
8.
ma'am.
8.
8.
Number 8 I should point. Is there any other null node? 13 I'm having free. And left pointer in order predecessor. What is in order predecessor of 11?
11.
I'm sorry, 13. It is 11. Correct. I'm just
11.
connecting to 11. So by doing like this, I can make the tree traversal very easy and faster. That is the purpose of this threaded binary tree. Guys, you got it?
Yes,
Yes,
ma'am.
ma'am.
Okay.